Now we're going to look at grooming the sensor data, and we're going to work through creating and preparing ownership sensor data ready for production of target motion analysis tracks, TMA tracks. So as always, we need to load our data files. So go into Navigator, find the nonsuch.rep file, double click, and when asked to select track mode, select Dead Reckoning this time, and then click on OK. And after a few seconds, the nonsuch.rep track will show. As you can see, it's in the outline view, and as always, we click Fit to Window so we can see the entire track. And you can just see there in the top right, the vessel in its start position. Now we need to import some sensor files. So back in the Navigator, drag in the sensor.dsf file. You can go through the options if you want, or you can just click on Finish. And as we can see, there's no difference to our plot editor, but we know that the sensor information is there. It's just hidden by default because it can become quickly cluttered when showing bearing lines. So now it's imported, we want to make the sensor data visible. So in the outline view, click on the down arrow next to track nonsuch, and then we can see sensors 1 item. We'll expand that, and then we can see we actually have 52 items in sensor 1. Click on sensor A, 52 items, right click, and then select Reveal Item. Now in our data you can clearly see one bearing fan heading off to the northwest and the other towards the northeast. Now this is typical of a towed sensor, as they produce both a true bearing to the target and a mirror reflection ambiguous bearing. So what we need to do now is we need to drop the ambiguous data. Now in this example, intelligence tells us that the actual contact is off to the northwest. So we can dismiss or drop the ambiguous data set of bearings that generally point to the northeast. Now Debrief makes this very easy for us. So if you haven't done already, click on the down arrow to expand the sensor data set. And then we need to left click on the top item, scroll down to the bottom, hold down the shift key, and left click on the bottom sensor data item to select them all. And then right click, and then we select Keep Starboard Bearing. Remember which way the vessel's moving. It's from northeast down to southwest. And there we go. All the port sensor data is hidden. So now we need to edit the raw sensor data. Now one method of editing this data is by using the grid editor. So we click on Window, Show View, and then we have the grid editor open. Unfortunately, it's blank because we haven't actually indicated any data to view. So what we need to do now is indicate the data that we want to edit. So I click on the track segment 220350 dot blah blah blah. And there we go. As soon as I clicked on the down arrow, the grid editor filled. If you want to cancel this behavior, you can click on the lock editor here in the view toolbar. But we're not going to do that, and then we're going to just click on sensor A information, and as you can see, the information in the grid editor is changing now between the track and the sensor data. As mentioned previously, the interface can become easily cluttered. If you've got a dual monitor or something like that, then it might be a good idea to just drag and drop the grid editor onto your other monitor, just to give yourself more room to work with. Now you can expand the grid editor in the normal way, so you can see all the data, but you can also use the scroll bars to scroll up and down. If you don't actually have enough room on your monitor like me, you can use the horizontal scroll bar like that. Most of the cells within the grid editor are editable, including the date and time. And if you actually click in the grid editor to select an item, on the view toolbar you will see the blue Insert Row button becomes available, and clicking on this will duplicate a row, and this is actually going to save you a lot of time when you need to add and analyze information, but we don't need that now, so I'm just going to right click and select Delete Row. In addition to straightforward text editing of data, selecting an attribute offers further editing capabilities. For example, if I look at the frequency column, if I click on the header itself, what then happens is I get a frequency graph appearing below it. This is called a waterfall display of frequency. And the most recent value is at the top, as you can see here, 0525, 0415 when we started. Now on this frequency graph, you can zoom in by dragging top left to bottom right, or you can zoom out bottom right, top left, as such. Now we're looking at all the frequency data. You'll see that while the data seems fairly constant near the top of this data set, the data value is too low here, around about 0.519, when viewed in the context of the steady track below it and the value above it. So as such, we're going to fix this data point by dragging it into a better position. Now we can do that from here if we want by clicking on it and dragging it, but it's going to be pretty imprecise. So of course we zoom in. And you can do this multiple times, and then we click and drag. And there we go. That looks good. Then we zoom out again, and it's looking good. We can also smooth a period of data as well by using the grid editor. And to do this, we need to switch to the bearing data view. So I click on the bearing column heading. Now I get my bearing waterfall display below the grid editor. Now if we look around the period 0510 to 0520, which is, as you can see with my mouse here, and we zoom in there, we can see there's 3 steps. 1, 2, 3. And what we're going to do is we're going to interpolate the data points between these two values, 0510 and 0521. And the way we do this is we come up to the grid editor and we find the first point, 0510, 44, and we left click on that to select it. And then we scroll up until we find the second point, which is about 0521.30, and then holding the control key down, we left click on the top value. As soon as I do that, you'll notice that the interpolate button on the view toolbar appears. I click on that and look what happens to the waterfall display for the bearing. Smooths the data out. But here we only selected a beginning point and an end point and then clicked on interpolate. And it did the interpolation based on those beginning and end values and those in between. However, if I undo this and I select multiple data points by holding down the control key and maybe even going beyond this, it's going to give us a better result because we're including more data points. So now we've tidied the sensor data, we can move on. And as we saw before, the sensor data was ambiguous. And this can happen when the data has been produced by a towed array. In this current scenario, Debrief is plotting the sensor cuts against the attack datum of the platform, but we need to apply an offset of 451 meters in this particular example for this sensor. And this is minus 451 because it's towed behind the vessel. And to do this, we need to click on Sensor A in the outline view. And we just need to be able to view the properties view a little bit better. And we'll just make sure that we can see the properties as well. And then you can see the sensor offset attribute. And we need to type in the value in there. And remember, it's a minus value. So we type in minus 451. And then we left click away from the value to apply that, to fix that attribute, to fix that value. And to see where the current array center is, we need to view it on the track. So we click on track nonsuch, and then where it says plot array center, click on that to select yes. And if we just zoom out a little bit and then zoom in on nonsuch, we can see there's the center. And if I come back to the property view and click on plot array center no, you can see what happens. There it is. So we'll be using the track and sensor data from this tutorial in the next tutorial. So ensure you save it if you're going to take a break and move on to something else. Just going to talk a moment about reducing data density. Because though it isn't necessary for this particular scenario, Debrief does allow you to reduce the density of sensor data. We do this by, in the outline view, we click on sensor A, right click on it, and then in sensor A, we select visible frequency, and then we can select the filter we require. So we're now looking at all of them. If we only want 1 minute, we just select 1 minute. And then we zoom out, and then you can see the effect of that. We change the visible frequency to 10 minutes. That's what happens. So we're removing all the sensor information between those 2 points. But I'm going to go back and I'm going to select visible frequency and select all. And that's what we have. As you've seen, the sensor cuts are not deleted, they're just hidden, and they can be made visible again just by selecting a different frequency as I just did. But a more permanent way of doing this is to actually right-click on the parent track and select Reposition Sample Data at the interval required. So if I wanted that at 5 minutes, that gives us lovely smooth sensor data. As mentioned earlier, this sensor data and track will be required for the next tutorial. So if you don't intend to jump straight onto it, ensure you save this file. I'm going to click on Save, and because this is a rep file, it must be saved in a different format, the DPF format. So I click on OK, and I'm just going to save this as nonsuch plus data. And then I have to select a project to save it in. And then I click on OK, and that's my data saved. In the next video, we'll look at generating a target track.